Hey, what's up? It's Jake from Nimbus DevOps. And now we are going to get into object oriented programming. So here we go. You've probably heard of this before. Maybe you have, maybe you haven't. I'll do simple.py. And if not, then I'll just do a quick explanation. Um, so in Python, we've said before that everything is an object, right? So it would stand to reason then that object-oriented programming would lend itself quite well to Python, and as it turns out, that's actually quite true. The more complicated version of explaining this is that object-oriented programming is kind of a paradigm based on the concept of objects, which are data structures that contain data. Okay, so that's the first part. The data could be in the form of an attribute, code, or in the form of a function known as a method. The distinguishing feature of objects is that an object's method can access and often modify the data attributes of the object with which they are associated. And in this case, objects have a notion of a self, like I know I am myself kind of self. So in object-oriented programming, computer programs are designed by making them out of objects that interact with one another. Kind of a meta way of looking at things, but Python fully supports this because, like I said, everything in Python is an object. And there's two main players in object-oriented programming that we're going to be talking about, and that's objects and classes. So rather than get into some super deep dive video, I'm just going to keep this one very simple. So classes are used to create objects, which we've done before, and objects are instances of the classes from which they were created. So we could see them as instance factories, if you want to think of it that way. And when objects are created by a class, they inherit the class attributes and the methods. They represent concrete items like in that program's domain. So that's all the complicated explanation stuff. Let's look at what this looks like. So I'm going to start with the simplest class you could possibly make. So this is the simplest class ever written on the face of the planet. So I'm going to make a class and I'm just going to call it simplest. And it just has an empty argument, which is totally optional. And I'm just going to say pass. That's it. That's all it does. So what can we do with this? Well, let's print the type of simplest so we can see what exactly it is. So we'll get the type. Let's create an instance of this class by saying simp equals simplest. And then let's also print the type of simp and see, is it the same? Is it different? What is the type of simp? And then we want to print the type simp is simplest and return some sort of, there's a better way of doing this, but we'll look at whether or not this Boolean expression evaluates to true or false. So let's run this code and then talk about what in the heck we're doing. So Python, simple. Okay, so class is type, class main simplest, and class bool. So we've printed the type, simp is simplest. We've done all this stuff. I think if I want this to evaluate, I need to do that. There, let's try that. There we go. True. So the simplest class we defined has only the pass instruction in the body, which means it doesn't have any custom attributes or methods. The brackets after the name are optional if they're empty. That's right here. We will print its type main here, which you see here. Main is the name of the scope in which the top level code executes. And we are aware of that in the highlighted comment, we wrote object instead of class. In a previous example that I did this. It turns out you can actually see by the result of the print statement that classes are actually objects. Okay. To be precise, they are an instance of type. Okay. Explaining this concept is kind of difficult because we're not going to talk about meta classes and meta programming. It requires a pretty solid grasp on fundamentals first, so I won't talk about that. But I will leave a pointer for you when you're ready to explore more deeply that meta classes and meta programming are something you can look into. So let's go back to this example. So we create simp, right? And this is an instance of the simplest class. Okay. Think of simplest like a template. And every time you create something from that template, it's not the template, it's that version of the template. So I could have simp1 simplest, simp2 simplest, simp3 simplest, and each one of those is different. They're all different instances with different object IDs and all that stuff, but they're all basically pointing to the same thing and saying I am an instantiation of the class simplest. So um, we can print what type simp belongs to and verify that simp is in fact an instance of simplest. And there's a better way of doing it that we'll get into in a little bit. Um, but up to now, it's all very simple. What happens when we write class name pass though? Python, what it does is it creates a class object and assigns it a name. And it's very similar to what happens when you declare a function. It's, I mean, you might look at this and be like, what's the difference between this and a function? Honestly, it's the same process when you think about it. So, anyways, that's all I'm going to get into. So just kind of take that information, digest it, internalize it, make sure you understand, and we will move on to class and object namespaces.